All right, geometry, back to lesson 7.3, video 2. So let's do some problems, right? Enough of this nonsense talk. Let's do some problems. So are triangle ABC and triangle DEF similar, right? So again, we have to think about, okay, there's three ways: angle, angle, side, 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 angle, side. Given the information, what would be the best option or route to go? And I think for this one, we should attack side, side, side similarity, right? So that's the question. Are these two going to be similar by side, side, side? So the reason I say this is because we have the three lengths of each triangle, right? So now we have to compare them correspondingly. Again, it doesn't matter what sides go on top, either triangle ABC's sides or triangle DEF sides. It really doesn't. I'm going to put triangle DEF's sides on top. So this correspondence here would say, okay, DE over AB. Right, just using the triangle names. Again, DE is the smallest side, AB is the smallest side, so it'd be smart to compare the two smaller sides. 4.5 over 3. If you divide 4.5 by 3, you get a factor or a ratio of 1.5, a simplified decimal, right? So now the question is, right, is that going to hold consistent, right? The idea is that if I take 3 times 1.5, I get 4.5. If I take 4 by 1.5, well, I get 6, right? Comparing the second two sides. If I take 5 and multiply by 7.5, will I get, or if I take 5 and multiply by 1.5, will I get 7? Well, let's see. Let's do the next set of sides. EF corresponding to BC, right? Well, EF is 6, BC is 4. When you divide those, you also get 1.5. So far, so good, right? They're equal. Great. Now let's do the last side, right? Let's do DF and AC. DF is 7.5, AC is 5. Use the calculator. When you divide them, you get 1.5. Great. This checks out. They all have the same simplified ratio. These sides are proportional. So what this means is that DE over AB equals EF over BC equals DF over AC. The three pairs of sides are proportional. So we do know that triangle ABC is similar to triangle DEF by side, side, side similarity, right? And this is the idea. This is what we're trying to show. Okay? No angles given. No angles at all, so we can't use angle or side angle, And again, if you look at this picture, small side to small side, medium side to medium side, big side to big side, right? Make sure you think of that when you compare these ratios. Okay, next. Are these two triangles similar? Okay, so triangle PQS and triangle RPQ. Now notice that they both involve PQ. So these two triangles actually overlap. So this is actually kind of a difficult problem to look at. But let's take a look. So PQS is the big triangle, right? So I'm going to draw that again. I could have also drawn RQP again, but I'm going to draw one of these triangles. So PQS. So this is PQS. Right? So in PQS, you have this is 18, and SQ would be the 15 plus 12. That would be at length of 27. Okay? And then up here, we want to compare it to triangle RQP. So just this triangle here, not this one, just this one right here. So let me actually do that in purple or something. So we don't care about that, right? So we have 8 and 12. Now, the one thing to really identify is the fact that where they overlap at. They overlap at angle Q. So right now, they have a pair of angles in common. Angle Q is congruent to angle Q. That's by the reflexive property. It's used in both. But that's the only angle we know anything about. So the fact that I have two sides here and two sides there, I think they're trying to see if these are similar by side angle side similarity. Let me fit that similarity symbol in there. Right? Can we use that? Well, let's see. Right? So now we have to look at the sides we have left. Right? One side is small and one side is big. In this top triangle, RQ is smaller, it's 12. In this one, PQ is smaller, it's 18. So we'd probably compare those two sides and then these two sides. Right? Do not compare 18 to 18. It doesn't match the correspondence, right? So let's do this triangle first, right? The RQP. So let's put RQ on top. Not RS, RQ. I swear I say these things and I don't even write them down, right? So I get it sometimes if you watch me like not writing down what I do. RQ over PQ. So RQ from the blue triangle is 12. PQ from the red triangle is 18. When you do that, you get 0.6 repeated. 0.666666. So now let's do the other given triangle from the blue triangle, and that would be QP. Over, and QP corresponds to QS in the first triangle, the bigger triangle. So in the blue triangle, QP is 18. In the red triangle, QS is 27. When you divide those, you also get 0.6 repeated, which means that these sides are proportional. RQ over PQ does equal QP over QS. And since these angles were congruent and these sides are proportional, then yes, triangle PQS is similar to triangle RQP by side angle side similarity. Okay, two more. All right, so here, those are like proving the triangle is similar. Now here's some true application. So what is the length of MN? So MN is right here, right? So what is that length? So first of all, are these two triangles similar? Well, let's look. They're both isosceles triangles, yes? So markings here, markings here. So this is also 75. These two sides are congruent, right? 1 and 1 there. Isosceles, this triangle. And now notice where these two triangles touch. They touch at L. This angle here, JLK, and this angle here, MLN, they're going to be congruent because what are those two angles? Those two angles are vertical angles. And vertical angles are congruent. So now look at this, right? We have a 75, a 1 and a 1, and a pair of congruent angles. If you look here, these sides are proportional. Ratio of 1 to 75, or 75 to 1, 75. So these two triangles are similar by side angle side similarity, right? So we can set up a proportion to find MN. If we want to find MN, it corresponds to JK. And all we do is set that equal to another pair of corresponding sides. Let's pick ML and JL. Well, MN we don't know, so leave it as MN, or you could call it X. JK we know is 10. ML is 1, and JL is 75. So we need to find the value of MN that makes this ratio the same as that one. Well, to solve a proportion, we're just going to cross multiply. That gets you 75 times MN equals 10. And then to get MN by itself, we're going to divide by 75. And MN comes out to be a decimal, 0.08, or you could have the fraction, which is 2 over 25. Divide both by 5. Or divide both by 5? So that'd be 2 over 15. Sorry, 2 over 15. My bad. Oh, let me go back. Slow down. Back. This would be 2 over 15. And let me double check. I don't think. So let me see. 2 over 15. Okay, so I'm wrong, right? So 10 divided by 75. 10 divided by 75 is 0.13 repeated. So 0.13 repeated. So I apologize if you were confused for a second. And that is 2 over 15. Okay. So again, sometimes my mental math fails me as well. But there you go. So that would be the length of MN based off this similarity connection. All right, last but not least, my favorite kind of question here with similarity. So it says Avery puts up a radio antenna tower in his yard. Whoa. Ella tells him that their city has a law limiting towers to 50 feet in height. How can Avery use the lengths of the shadow and the shadow of the tower of his shadow and the shadow of the tower to show that his tower is within the limit without directly measuring it. This is called indirect measurement, right? So we have these two triangles. Now notice how they're marked, right? So this angle here, angle A and angle R, we call those the angles of elevation of the sun. They are going to be congruent based off of the sun at that current time. And then we assume the tower and Avery are vertical to the horizontal ground. That means they're perpendicular. That means you have two right angles. And therefore, these two triangles are similar by angle-angle similarity. So now we can set up a proportion to find this missing height and verify that it's less than 50 feet. So I'm going to say that ST, okay, now ST corresponds to this height, which would be BC, or we could just put 6. So ST over 6 equals, now go back to the big triangle, equals 40, and 40 corresponds to 5. And there's our proportion. Cross multiply, 5 times ST equals, that's ST, 6 times 40 is 240. Divide by 5 on both sides, and we get an ST value of 48. And because 48 is less than 50 feet, we are within. Okay? So we have a tower of 48 feet, which is within the 50 feet limit. So he's good. So there we go. All about similarity in this section in triangles. All right, thanks for watching. We'll see you in class for the classwork.